So a couple of years ago, we machined a new lead screw for the American Pacemaker compound slide. And when we did that job, I went ahead and invested in a new tool and carbide inserts to machine a Acme thread. So I got the Tool-Flo. This is the MTVOL, and it holds the TNMA style of inserts, a number 5 seat. So this is a TNMA 54. And these particular inserts are made to cut a 5-pitch Acme thread. All right, so we're here we are today getting ready to cut another 5-pitch Acme thread. I've already got the inserts, but I didn't have a right-handed tool. So I went ahead and bought another one. We now have the right hand, MTVOR. Right hand being you're cutting from the right to the left. This is our left hand, cutting from the left to the right. And I wanted to go ahead and get the stick tool because I already had the inserts. And there's just some jobs that I'd really do like the convenience of carbide inserts. I mean, most of us do with the lathe when you're doing your turning and threading anyway. And you know, one of those conveniences is that if you happen to, during the job, the carbide insert chips or breaks, messes the edge up, you're already lined up with your thread. You can simply take the insert out, index it, or put a new one in there, tighten it up, and you're still lined up near perfect on your thread there. When you have a high-speed steel tool clamped in a tool holder and something happens and you're going to have to sharpen it or something, then you have to line the thread back up, and it makes your job just that much harder. So when you're doing threading, the modern conveniences of an insert tool really does help out tremendously for that kind of job. So got the right-handed tool, but the first thing that we need to do is go ahead and machine the bottom of it. So on the Precision Matthews lathe with a 1-inch shank tool, that's what this is, I can't lower the tool holder down far enough for the center line of the insert to be in the center. And that's why whenever I got this one, I set it up and machined the bottom of it. We took about 1/8 of an inch off the bottom of it. We actually used the shaper to do this, which is a really great machine to do jobs like this. We took a high-speed steel tool bit and made a pass across there and cut that down in no time, got it done. We didn't burn up or ruin any inserts or end mills for that matter. So that's a really good use for a shaper, is doing stuff like that. But we don't have the shaper here in the new shop. We're just going to use the milling machine. So we'll go over to the mill, set this upside down, and let's take about 1/8 of an inch off the bottom of that. I've got a Walther face mill set up. We'll just use that to do the cutting today. So anyway, let's get this done first. Let's get our tool ready to use, and then we'll move on and get started on our Acme thread. All right, we'll use our handy snap jaws here for this. It's already got the 1/4 inch deep step machined in it. So we're not going to be going all the way across, by the way. I'm only going to go, I'm just going to match this shoulder right there. Don't want to get into the pocket that the insert's into. You also don't want to come up close to that insert. So we're only focused on the shank of the tool, not the head of the tool there. Get that tightened up. Whenever I machined this other left-handed tool, so we made this 0.825, so we've got 175 thousandths to take off of it. I thought it was 1/8 of an inch, but we needed a little bit more than that to give it a little bit of adjustment there. So got it touched off. We'll just do that in either 2 or 3 cuts. Don't know how it's going to handle over here in the mill, but we're about to find out. First cut, let's try 100 thousandths and see if the mill will handle it. Always try your feed the opposite direction first so you don't ram your tool in there going with a fast, rapid feed. I had a zero location already established. I'm going to go ahead and straighten up that corner. Bringing it up to my zero and go across. All right, so that face mill is working good. I think what we'll do is we'll take a 65 thou cut now, and then I'll come back at 10 thousandths and just kind of like leave a cleanup pass, because it seems to, when you're taking a heavy cut, it seems to move around a little bit and leave a line in there that you can feel. So we'll take just a light cleanup cut when we're done. Feed it a little bit harder here. All right, we'll come back. Let's go up another 10 thou and clean it up. Okay, our cleanup pass. Just gonna run back across it, try to even out that cut. That's some tough steel that you're machining. That's tool steel. Let's try to keep as an even surface as we can there. There we go. All right, that worked out good. So we'll get it out of there. I'm gonna have to do some filing and deburring on that. It always leaves a really hard serrated edge on that. But we're just about ready to set up on the lathe now. All right, there's our milled and filed tool. We're gonna use this tool holder right here. Let's get her locked down and see if we can get it on center line. Okay. Just going to use the live center for this. That is so close, right where it's at. You guys were right where I need to be, so I got to move you. Just got to get down here next to it and be able to line up that top edge. It's looking good. That looks good right about there. We'll go ahead and lock this guy right there. All right, well, our tool's ready now anyway, but we're gonna have to, we gotta set up our compound. I am gonna use compound end feed for this. The flank of the thread for the Acme is 14.5 degrees per side there. So we need to set our compound on 14.5 degrees for our end feed. And once we do that, I'll go ahead and indicate our tool post and make sure that it's nice and straight, perpendicular to the shaft. Man, that side was tight. All right, let's get this tool squared up. Just just going to eyeball it about as square as I can see it, and then we'll get a indicator on here, and we'll just go ahead and indicate the side of the tool. Hopefully it's machined nice and square to the seat. That's as far as back as I can get it. That's 3/1000ths right there. That's not bad at all. I mean, that's good enough to just go ahead and run it, but let's see if we can get it a little closer. So it's about 2 thou. One thou. So I think we're just gonna leave it right there where it's at, because you're just gonna go back and forth chasing your tail. But it looks like we got it right about there. Tighten it down. Make sure we didn't pull it. Nice and square. All right. So just so you know, this is what I like doing with my threading tools. Actually, let me take that back. When I have my compound set up on the cross slide right here, I always keep the cross slide set at the 29.5 degrees for end feed threading, compound end feed threading. I also make sure that my tool, once this is set, I go ahead and I indicate the tool right here so that it's nice and square for threading tools and also grooving tools and parting tools. You know, if you come in there with a grooving tool, you know, something like that right there, you want the nose of it to be nice and square to the cut. So that's why I always keep this nice and indicated. So when I drop a tool in, I know that it's perpendicular to the surface, about as perfect as we can get for what we have. All right, so tool is ready to go. I think we're just about ready to start cutting some Acme thread now. Let's go over a couple of Acme thread basics before we get started. So as mentioned, we're cutting a 5-pitch Acme thread. That's 5 threads per inch. So I have this really handy Acme thread gauge made by SPI. All right, our 5 threads per inch. So we can use this as our screw pitch gauge. Every size Acme thread, the tool is a different width. So you can get this gauge right here from the Ellisteric company, and it has all of your Acme thread sizes on here. Okay, from 10 all the way up to 1. We're cutting a 5, so what this tool does is it gives you the width of the nose of the tool. So this is the tool made for a 5 Acme thread, and it'll line up into that 5 perfectly. So if you're hand grinding your tools, if you're going to use a high-speed steel and you're going to grind your own tool bit, you can use this as a gauge. This right here is your 14.5 degree flank angle, and this one as well. So you can use this one if you're grinding a tool bit. You can use this as your gauge to make sure that your angle is correct. You can also use it on the lathe. You can push this up against the workpiece and make sure that your tool is lined up perfectly, perpendicular. All right, so a really handy gauge, a little bit more old school, but it's handy to have these things in the toolbox for checking your tools if you're going to be grinding them and things like that. All right, the other thing to note is the pitch. So our pitch is 5, our pitch is 5, so that means our lead is 0.2 inches. To get your lead, you take 1 divided by the pitch that you're cutting, which is 5, equals 0.2, all right? A lot of your lead screws on your compound slide, some of your lathes, is 200 thousandths per revolution. That's because it's a 5-pitch Acme thread. So to get the depth of your thread, you just divide that in half. Ours is really easy, right? 0.2, so you just divide by 2 is 0.1. So that's our thread depth, or the thread depth per side, which would be like this right here. It's 0.1, plus you have an additional 10 to 20 thousandths that you go deeper for clearance for the Acme thread. And that's all in the machinery's handbook. It goes over in detail the depth, the pitch, and the extra that you give it for clearance, all right? So just wanted to point out a couple of things. So you know, we're going to be going on the dial, 200 thousandths on the dial, or 100 thousandths per side, and then we'll go in a little extra for the clearance. and then make sure that our nut that we machine fits on that screw good. So this is going to be acting like our thread gauge, and just make sure that we have a really nice fit on this nut right here. All right, so just a couple of the basics for Acme threads. I think we're ready to start making some chips now. All right, let's get everything touched off. We'll start with our follow rest. We're going to go ahead and run that up gently. Just touch it. And I'm going to go ahead and just snug these set screws just lightly. Try to keep those fingers kind of in place. All right. And I need to get another Allen wrench. The cross slide of the, trying to find the right tool here. The collar on the cross slide that I'm going to be using for end feed is actually, it's got a set screw. This is the collar I'm talking about. It's got a set screw that locks it, which is the one thing that I don't like. I wish that they had just made this as a friction collar instead of having to loosen that set screw, because it's either tight or it's super loose. There is no in between. So I just wanted to get that ready so I can line up my zero there. And let's get our tool touched off. All right, so first thing I'm going to do is set my cross slide. I'm going to set it to a 0. I like setting it so that the handle is on the left side so that I can just go down, which retracts the tool. I'm going to go ahead and 0 my DRO. Okay, 0'd that. And now we can go ahead and get our tool touched off. So we're going to run this up. Just touch that shaft. Right there, I see some chips. Now I'm going to go ahead and set the collar here to 0. All right. And we're going to do the same thing we do when we cut V-thread. We're just going to make a little short pass across here and check our thread and make sure that we're lined up on 5 threads per inch, okay? So I'm going to go ahead and dial that in about 2 thou. Now we got to get our lathe set up. All right, so we're cutting a 5 thread right there, inch 5, HBS3V. So HBS3V. Should be 5 threads per inch. All right, on the half nut right here, or your thread dial, you can engage, once you start, you can engage every other line. So we'll start on number 1. That means we can re-engage our half nuts on 1, 2, 3, or 4, and it'll line up every time. There's a chart underneath here. I'll show you a picture of it that even tells you what divisions you can line up on depending on the pitch thread that you're cutting. All right, we'll make a scratch pass and check it. I did bump it up 1 speed, so we're running 180 RPM. We'll try that and see how the machine reacts. All right, just going to stop it there. We'll grab our screw pitch gauge for Acme. I have to go in just a little bit, but you can see, I think you guys can see, it's lined up. So we know that we have our machine set right, and we are ready to go. Let's go ahead and reset. We're going to bring this back. Come back into our 0 on the cross slide. Let me go ahead and get some coolant ready. We are going to use our flood coolant here. I want it right on that tool there, and then also to lubricate the workpiece for the follow rest. So let's go ahead and take a cut. I'm going to go 20 thousandths on the compound. And let's start there. Give me a little run-in room right here. Start back on number 1 on the half nut. Watch it for it to come out in that thread relief right there. Now, while we're right here, we got thread, or the chip. That looks pretty cool. But now, while we're lined up in the thread relief, I'm going to go ahead and take this mag back indicator and set a 0, because it's also, as I said before, it's a nice visual representation of where your stop is. Those magnets are pretty tough. So as we're threading, I can just be looking down here instead of up, or, you know, we're looking at this, but we can also look down and see this thread dial, this dial indicator lined up as well. All right, so retract the tool. I'm just going to go ahead and turn it on. It's probably going to be wearing on those bronze pads, because that's going to leave a burr whenever you're cutting these threads. So I'm probably going to have to be sure that we check this adjustment and make sure it's tight. And just bring this back into 0. And we're going to take another 20 thousandths. Trying to get aggressive right off the bat here and see how it does. It's doing great. As long as that follow rest gives it support like it's supposed to have, it should be good to go. Yeah, I saw it pushing on it right there. I think that finger, I think what it did is it caught that edge. I think it caught this edge right here. Yeah, you can feel it. All right, let's repeat, do it again. It's rolling up quite a burr, so I'm taking this mill smooth file and I'm just trying to knock that burr off the threads, because all it's doing is just eating up those bronze pads on that follow rest, and it's not staying on size. It's doing good, but I'm just trying to mitigate any further issues with that follow rest. Since I'm just machining one screw, probably take my time and do that on every pass. I disengaged the half nuts because I saw it really pushing on that follow rust, and I just, well, you can see what happened right there. I stopped it right at the end. We may just come back in here later and just widen out this thread relief and clean that up if it looks too bad. Last couple passes I've been using, I went back to straight end feed because I noticed on the right flank, it was leaving, it wasn't actually up against the flank of the thread that we're cutting. It started leaving a little tiny step in there. So instead of feeding at an angle, I've just been going in about 5/1000 a pass so that the full profile of the insert should start cutting again. I'm going to check the depth. This is where I'm saying your depth of the thread should be 100 thousandths plus clearance. So technically, according to the book, if we measure this, should be 100 thousandths plus between 10 and 20 thousandths for clearance on top of that. So I measured it right there, just using calipers. This doesn't have to be exact, but so right around 90 thousandths. So we still got at least 10 thousandths to go to get to the nominal depth that we need to be, plus probably a little bit extra for clearance. But it's looking good. That insert's doing a good job. The flank of the threads look nice and shiny, just like I was hoping. So probably a few more passes and I think we might be there. So right now we're right at that 100 thousandths depth, thread depth. So we're getting really close. Here's our nut. And if we try to screw it on there, it's getting tight. So we still got to go a little deeper, give it a little clearance. We're getting right on the cusp of it fitting together, but we definitely need a little clearance in there. Checking it again, just making a pass and taking like 5 thousandths a pass. Tight. I don't want to force it on there. We need to go another 5 thou on that. All right, I think we should be there. We got it. There it is. We got a good fit on that. Boy, am I relieved. It's good to finally see those Acme threads come to shape, come to size where it needs to be. There we go. A little bit of filing, a little bit of polishing, get rid of any of the burrs on the edge of those threads, and this guy's just about ready to go. I think we are well on our way to having a new spindle for our hardtail vise. It looks good. I'm real happy with it. I took a little time, did some detail filing on the ends there to soften up those sharp edges. Right here where that thread comes to a really sharp V, like a razor, I went ahead and did a little filing there to kind of knock that sharp edge off of it. Polished it with some emery to soften that up so I don't cut my fingers on it. And then just ran the Scotch-Brite over the top just to try to blend it. The top, corners of the thread there, it kind of softens that edge up where it's not so sharp, and it looks good. I am really happy with this. So I think it's time to take it out of here, and we can look at it next to the other spindle just for comparison. But from here, I plan on going over to our CNC lathe to finish this meatball in. But let's go ahead and get it out of the lathe. Move our center back. There we have it. Nice. Okay, well there she is next to the original spindle. I think mine looks better. Maybe I'm biased, but since I made mine, I like mine better. A little bit shinier too. I'm real happy with the Acme thread. I think it worked out pretty good. These can be a little troublesome when you're trying to cut. Right here, right in this area, the last, I'd say 1, 2, 3 threads, you have just a little bit of chatter in the bottom of that thread there. There was nothing I can do to get it out of there. We had the fall arrest up to where it needed to be, but something about this area here and coming across this opening, this groove, it allowed it to chatter just a little bit, but that's not a big deal. We're not even concerned about that. I'm happy that they turned out good. They're on size. It looks good. So we're well on our way. So the next phase for the spindle itself is obviously machining this ball end on there that we call the meatball. That is a program that I've already proven. You can see there, this is what we're going to try to duplicate, just like that on the end. And I wanted to make sure that I had this right. I didn't want to stick this in there and mess it up after putting all this work into it. So I'm going to be sure that our program is right before we do that. And the other thing that I'm almost positive that we're going to have to do in order to spin this in the CNC, we're going to have to make some kind of spindle liner, like a bushing, probably a plastic bushing, nylon or whatever I can find, that will support this outer end in there. Because after doing that threading, I could see just a tiny bit of run out in there. Probably somewhere between 5 and 10 thousandths of run out, which is normal for something like that. It tries to move on you as you get in there and you're using a tool to cut that thread. So that means you're going to have a little bit of whipping action. Our CNC is going to be spinning up to about 2,500 RPM. So I need to make some kind of support. So when this is slid through the spindle there, you've got a bushing out here that's captured it, that's going to keep it center to keep it from whipping around and vibrating and causing problems inside the lathe. So that's something that we're going to have to do in order to get this machined in our CNC. So I think that's it. The other thing that we still need to do is we need to finish modifying our new nut with the hardtail nut right here. So I think I spoke about this before. What I plan on doing, we're going to set this up in the lathe. We're going to part this threaded end off, which is about 3 inches in length, and we're just going to modify it. We're going to machine this and this with some threads so that they screw together. We'll maybe pin it somehow to keep it locked together, maybe use some Loctite. And then once we get the two screwed together, we can go ahead and just finish turning this OD down to match that. So that's the plan for that. So we still got to work on that as well. But I wanted to use this as our thread gauge for our new Acme thread before I had this fixed to the hardtail nut there. All right, so that's it. I hope you guys enjoyed today's video. I hope you enjoyed watching the Acme thread, and hopefully some of those videos that I took turned out pretty nice and you get some detailed shots in the video. So we'll see you back here on the next project, all right? See you then.